Finger joiner cutter head blade calibration is a vitally critical process where each knife blade on the head is sanded, weighed, sharpened, and calibrated to within 1/10 of a gram in weight. Even a slightly dull, slightly off-balanced, or small change of the hook angle can cause the finger joints to improperly align. Loosen and remove the center nut of the top plate of the setup stand and the 6 nuts holding the knives to the cutter head. The nuts are numbered and must be placed in the appropriate peg on the knife pegboard. Remove the retaining plate and set aside. The knife stack bolts are also individually numbered for reference. Beginning with bolt number 1, remove all knives and spacers above the first stabilizer and place them on peg A1. Do not remove the spacers from in between the knives, but keep the stack of knives and spacers intact. Repeat this process with the 5 knives from bolts 2 through 6, placing each stack of knives and spacers on the correctly numbered peg. It is important for future steps that each stack of knives face the same direction when placed on the pegboard. Remove the stabilizer that connects bolt number 1 with bolt number 2 and place it between pegs number 1 and 2 as shown. The stabilizer connecting number 3 and number 4 goes between pegs number 3 and 4, and the stabilizer connecting number 5 and 6 goes between peg number 5 and 6. Repeat these steps for knife layers B, C, and D until the cutter head is empty and the knife pegboard is full. Clean the empty cutter head with WD-40 or another approved parts cleaner. Clean thoroughly, being sure to remove all solid debris. Use an air hose to completely dry the cutter head once it is fully cleaned. Any residual cleaner or oil left over will cause sawdust and other particulates to stick to the cutter head and gum up the knives. It is now time to clean the knives and spacers. Fill the ultrasonic parts cleaner with cleaning solution and using a piece of wire, string knife stacks A1 and A2 onto the wire. Be sure to separate the stacks so as not to mix them up. Set the timer on the parts cleaner to 10 minutes and the ultrasonic cleaner will start automatically. Once the timer goes off, remove the stacks and place them on a clean cloth. Place the next 2 stacks, A3 and A4, on the wire in the same manner as before and start the ultrasonic cleaner for another 10 minutes. While the ultrasonic cleaner begins its next cycle, thoroughly dry each knife blade and spacer that was just cleaned. While drying them, wipe or scrub away any remaining residue or buildup with the cloth. You may need to use a razor blade in order to carefully scrape off any stubborn pitch or residue that remains. Be careful not to mix up the order that the blades appear in the stacks or mix knives from one stack into another stack. To deburr the knives and spacers, place 800 grit sandpaper face up on the marble stone worktop. Applying downward pressure, sand both sides of each knife in a figure 8 motion. The figure 8 motion is to ensure the knives get deburred from every direction possible, so the sandpaper does not create an uneven surface. Only sand the surface of the knife that comes in contact with either a spacer or a stabilizer, and do not sand the blade edges. The metal surface has been sufficiently deburred when you can no longer feel any resistance or friction during the figure 8s, and the piece smoothly glides over the sandpaper. This will take some practice to determine when deburring has been successfully achieved. Once all knives and spacers in the stack have been sanded on both sides, reassemble the stack and place it back onto its corresponding peg, but this time facing a different direction than the uncleaned blades. This will make it easy to distinguish the sanded knife stacks from the non-sanded knife stacks. This process should take roughly 5 minutes per stack, so there is a continuous cycle of stacks being cleaned and stacks being deburred. Stabilizers are cleaned in the same way, with only the surface that touches knives or washers being deburred. Repeat the process for every stack of knives and spacers until all have been cleaned and deburred. Once finished, it's time to weigh the knives. Zero out the scale and place one knife at a time onto the scale plate. Record the weight of each individual knife on the cutter head balance record spreadsheet, being sure to keep the blades in the same order they were stacked the entire time. After the spreadsheet is filled out, calculate and record the total weight for each bolt stack. Keep in mind, there is no reason to weigh spacers or stabilizers unless one has been chipped or gouged since its last calibration. Now that you know the weight of each knife and assembled bolt stack, the objective is to balance the weight of the cutter head by ensuring each bolt stack weighs within 1/10 of a gram of the other two bolts on the same centrifugal plane. What that means is, bolt number 1 should be within 1/10 of a gram of bolts 3 and 5, and bolt number 2 should be within 1/10 of a gram of bolts 4 and 6. If any stacks have a weight difference of more than 1/10 of a gram, they need to be balanced. This is accomplished by swapping heavier knives from the heaviest bolt stacks with lighter knives from the lightest bolt stacks until the total stack weight is within 1/10 of a gram of the other two stacks. Each time a knife from one bolt is swapped for a knife on another bolt, the change must also be reflected on the cutter head balance record spreadsheet. For example, if knife C2 weighs 21.2 grams and is swapped with knife A5 that weighs 21.0 grams, the total stack weight of bolt number 2 will fall by 0.2 grams, while the weight of bolt stack number 5 will increase by 0.2 grams. To demonstrate how little it takes to be out of calibration, consider that this tiny knife fragment weighs less than 2/10 of a gram, or twice the allowed limit, which in actuality is less than the weight of a dollar bill. But even this tiny shift of weight on a cutter head spinning at 7,200 revolutions per minute is enough to cause catastrophic damage to the finger jointer's internal bearings. Once balanced, you need to transfer the data from the cutter head balance record into the Excel spreadsheet. This portion of the cutter head balancing procedure will either be performed by a member of management, or you will get hands-on training in this process at a later date. After organizing stacks and spacers back onto the cutter head, reinstall the top plate and loosely twist the nuts back onto their corresponding bolts. Slide the cutter head back onto the setup stand center post and install the stand's top plate. Before tightening, push the knife snugly against each of the posts on the setup stand. This process is called posting.
This post is what I'm posting to. All these knives gotta go up against this post. As I'm torquing it, I have to measure with a feeler gauge. It can't deviate any more than 8 thousandths of an inch. I like to 4 or less.
Using a wrench and a rubber mallet, tighten the center bolt of the setup stand's top plate by tapping the plate with the mallet as you tighten. The blunt force and vibration of the hammer causes the plate to settle and compress any gaps that may be in between the knives or spacers. Tighten the plate until it is as snug as possible. This will help keep the knives from rotating out of position for the next steps. A torque wrench is used in 25-pound increments to tighten the 6 bolts of the cutter head. Tighten the bolts in a 5-3-1-4-2-6 star tightening pattern, similar to how car and truck tires are tightened. Increase the torque wrench's force by 25 pounds each time all 6 nuts have been tightened. Continue this pattern until all nuts have been torqued to a total of 125 pounds. Attempt to insert an 8 thousandths of an inch feeler gauge in between the knife and its post. Be sure to check each individual knife. If the feeler gauge is able to pass between the knife and the post, you will need to leverage the knife against the post using a breaker bar available in the tool room. Continue until every knife is resting against every post. Sometimes this also requires loosening the 6 nuts, reposting the knife, and then retightening to 125 torque pounds. Keep in mind, 8 1/1000ths of an inch is the maximum tolerance, but you should always attempt to be at or as close to 0 thousandths of an inch as possible. After all knives have been properly posted, remove the cutter head from the setup stand and prepare the headstock grinder for use. Set your starting angle to 0 and ensure the angle adjustment knob angles the grinding arbor in either direction. Slide the cutter head onto the headstock grinding arbor and use appropriate spacers to span the rest of the arbor's length. Install and tighten both the arbor retaining nut and locking clamp mechanism. With the grinding arbor in the unlocked and freely rotating position, eyeball the edge of the knives to line up with the side of the grinding wheel's grinding surface. Your objective is to have as much of the knive's grinding surface touching the grinding wheel at the same time. Using the radial adjustment wheel, you can bump the grinder into the correct position and then fine-tune the adjustment with the vertical and horizontal headstock adjustment knobs. Once you are satisfied that the grinding wheel is perfectly aligned with the properly posted cutters, tighten the clamping mechanism to prevent the cutter head from moving out of position. The cutter head is also known as an ace-lock hydraulic sleeve and uses hydraulic pressure to further lock into position. Using the metered grease gun, inject 200 BAR of pressure into the cutter head or hydraulic sleeve. BAR is the metric equivalent to PSI. This will hydrolock the cutter head from rotating out of position during grinding. And after being locked in place, the entire grinding arbor can be rotated to grind each individual knife stack without affecting the grinding angle. Use a permanent marker on each knife face to help identify how much material is being removed and on which particular area of the knife it's being removed from. This will make it more clear if any other adjustments are needed for proper grinding. To adjust the depth of the grinding wheel, use a 10/1000 feeler gauge. The feeler gauge ensures the grinder removes enough material to sharpen the minimum required 9 mm of knife. So be sure to set the radial grinding arm to 0 before making your first pass. Your goal should be to only remove a small amount of material with each pass. You will notice how the grinding wheel is only making contact with a few of the knives on the first pass. This is because although the knives may have been posted to within 8/1000ths of an inch, a knife set that is at 0/1000ths of an inch will always be closer to the grinding wheel until enough passes have been completed to bring all knives onto an equal plane. Continue working the cutter head back and forth across the grinding wheel until it stops producing most, if not all, sparks. To determine if more adjustments must be made, or if enough material has already been removed at the proper angle, use the hook gauge. It is important to slide the gauge down the face of the knife and not the cutter radius, or curved part of the knife. As you can see here, gauging a knife from the cutter radius can lead to a false reading, leading you to believe the knife is in compliance. However, when the same knife is gauged from the face edge, it reveals that the grinding head angle needs to be corrected and the knife is in fact out of calibration. Too sharp of a hook angle will cut concave fingers, while blunt hook angles will cut convex fingers. Either incorrectly sharpened knives would create finger joints that cannot joint properly. This is why practicing proper hook gauge technique is critical for the finger jointing process. Another important factor to note about hook angle is that as the cutter head spins during operation, the central point of the rotation is not from the center of the bolt, but rather the center of the cutter head as a whole. If we draw a line from one knife tip to the opposite knife tip, our lines all intersect at the center of the cutter head. Therefore, the hook angle is based on the knife's need to align with the absolute center of the cutter head. Improper use of the hook gauge will eventually cause the knife tips to contact material at a point during the rotation where the tip is no longer at its apex and is also out of balance. This would result in a cut more shallow than the required 9 mm depth and a failed finger joint alignment. If the hook gauge reveals a change is needed to the grinding wheel or angle of the cutter head, use the headstock grinder's adjustment wheels to make the necessary changes until it is grinding material at the correct depth and angle. Finding this exact setting can be both a challenge and a test of patience, but like everything else, it gets easier with experience and time. Remove only tiny amounts of material each time, use the hook gauge often, and lean on the experienced staff members around you for guidance and tips as you master the critical precision of finger joiner cutter head calibration.